In level 2, you will need to do linear regression on a calculator. In this problem, the independent variable is given in years, and when the independent variable is given in years, you want to make your starting year year 0, and 1930 is 10 years after 1920, which we called year 0, so we're going to call that 10. 1940 is 20 years later, so 20, 30, 40, 50, 60, 70, and 80. And we want to enter this data in the calculator. So turn on your Nspire, and you're going to go to your home screen, which is the on button, and we're going to do a new document. And this is asking me if I want to save an old one, and I'm going to say no. And you're going to choose number 4, Add Lists and Spreadsheets. And at the very top where it says A, you're going to name your independent variable, which I'm just going to call X because it's nice and simple. And I press Enter, and I'm going to name column B Y. And that goes on the very top. I don't put anything in this gray box because if I do put something there, it fills that whole column with that item. Say I put a 2 there, it would make the whole column 2s. I don't want that. So I go down to number 1 and I enter my independent variable, my X values, which are 0, 10, 20, 30, 40, 50, 60, 70, and 80. And then I go back to my Y values and enter those, 54.1, 59.7, 62.9, 68.2, 69.7, 70.8, 73.7, 75.4, and 76.9. Be careful entering your data. Make sure you enter it accurately, and you should always have the same number of X values and Y values or it won't work. So the next step is going to be to add a calculator page to the document. And to do that, you are going to go to Doc, which is right under your On button, and choose Insert. So number 4, Insert. And we're going to insert a calculator page. So number 3 for calculator. And if you see at the top, it has tabs. 1.1 was our spreadsheet. 1.2 is now our calculator page where we're going to do the linear regression. So we go to Menu, and then we choose number 6 for Statistics, and then number 1, Stat Calculations, and the third one is linear regression in the form mx plus b, which is slope-intercept form, so we're going to choose that. And you have to tell the calculator what you named your X list and what you named your Y list, and we named them X and Y. So I'm going to do X, enter, X and Y, and then press enter, or highlight OK. And it gives you the values of M and B. I know it's very small and it's hard to read, but if you're doing it on your calculator, you should see that M is about 0.27 and B is about 50, well, is exactly 57.1 in this case. So the equation in slope-intercept form is y equals 0.27 x plus 57.1. And the slope of this regression equation is the m, or the number we put in front of x, which is 0.27. And what does it mean in the context of this problem? Well, this problem is about how the life expectancy is changing. So since it's increasing, this would Remember that slope is a rate of change, so this represents the rate of increase of the life expectancy. Life expect in the U.S. Running out of room per year. So how much does the life expectancy increase each year? Every year it increases by 0.27 according to this model. Use the equation you wrote to estimate the average life expectancy in the year 2004. In the year 2004, we want to think how many years after 1920 that is, since we made 1920 year 0. That would be 84 years after 1920. So I'm going to use x equals 84, and I'm going to plug that into my equation. So I get 0.27 times 84 plus 57.1, and we plug that in our calculator, and we're already in a calculate page. You could do it in your regular calculate screen, but it should be fine to do it here. 0.27 times 84 plus 57.1, and we get 79.78. And in what year will the average life expectancy reach 100 according to this model? In this case, we're going to put 100 in for y and set that equal to our equation, 0.27x plus 57.1, and we solve for x. So we subtract 57.1 from both sides, and we get 42.9 equals 0.27x, and divide both sides by 0.27, and we get x is approximately 158.8. And if this is supposed to be the year, that means 158 years after 1920. So if we add 1920 plus 158, it would actually be the year 2078.